Welcome back to the Advanced Higher Maths course, and today we will be looking at 4.1, which is standard integrals. So we are now entering topic 4, which is going to be integration, which is a fascinating topic, although we have to admit it is somewhat of a difficult topic, but very exciting stuff in it. So let's get into it. We're starting with standard integrals, which are basically common integrals of functions that you will probably get in the exam that you need to know to then apply other techniques, which we will learn after. So it's the same as standard integrals, and the standard same as standard derivatives, and the standard integrals are given in the data booklet. So the 5 standard integrals that you are given are the integrals of secant squared of ax, the integral of 1 over root a squared minus x squared, the integral of 1 over a squared plus x squared, the integral of 1 over x, and the integral of e to the ax. So, remember that an integral is an antiderivative. It's, in some senses, the opposite of the derivative. So, the first one that's given in the booklet is secant squared of ax. So we need to think of what integrates to give secant squared of ax. So, first of all, we need to think of tan of x, right? We know it's going to include, well, probably going to go to something to do with tangent of x, because the integral of tangent of x is secant squared of x. But here we have an ax, which means we'll need ax inside here, right? But by the product rule, we actually also need, by the chain rule, we need 1 over a here, because the a is going to be multiplied at the end, because it's going to be our v prime. So v prime is going to be multiplied, so we get a over a, which is going to cancel to give us secant squared. So we can show this by taking the derivative of 1 over a tan a of x. So let's say u prime is equal to u is equal to tangent of x. So u prime is equal to secant squared of x. Then v is equal to ax, and so 1 over a is a constant, so 1 over a is going to be multiplied at the end by tan of ax. So u prime of v, so secant squared of v, which is ax, times v prime, which is a here. So the 1 over a and the a cancel, which gives secant squared of ax, which means it is indeed. But that's not all, because remember, it's an integral, so we need the plus c. So this means that the integral of secant squared ax with respect to x is 1 over a tan of ax plus c. Now, we won't go through the whole deriving it every time, but I'm going to show you the others. So we have 1 over root a squared minus x squared. Its integral, so the integral of this with respect to x is equal to sine inverse of x over a plus c. Now you can see the general shape. Remember that a is a constant, by the way. X is a variable and a is just some constant. It's going to be different for every question. So do remember at least that sine inverse, the derivative of sine inverse of x, is 1 divided by the square root of 1 minus x squared. So we can sort of see where this came from. Now, the integral of 1 over a squared plus x squared, I put the plus, never mind. 1 over a squared plus x squared dx is 1 over a tangent inverse of x over a plus c. And once again, we can see the general shape, because the derivative of tangent inverse of x is equal to 1 over 1 plus x squared. So we understand where this comes from, roughly. And then the integral of 1 over x with respect to x is equal to the natural logarithm of the absolute value of x plus c. So the absolute value here is very important, because otherwise it's not the same. So now we have the integral of e to the ax as the last one. Now this is 1 over a e to the ax plus c, because of course the derivative of e to the ax is a e to the ax, and so to cancel we put 1 over a, so it's just e to the ax. So let's look at one or two example questions that use these standard integrals. So let's say we are asked to integrate 10 over 25 plus x squared with respect to x. By the way, I should point out the integrals part of the course becomes much more interesting later. This is sort of the annoying kind of memorizing stuff part, or even not memorizing, it's in the data booklet, but sort of repetitive learning. It's going to get much more interesting after. So, what is this equal to? Well, we saw from our standard integrals, we can see the general shape is going to be here, right? Because the integral of 1 over a squared plus x squared is equal to all this business here. A squared here is clearly going to be 5, because 5 squared is 25, and plus x squared is here. So, a is going to be equal to 5, but we have something different. We have 10 on the numerator. Well, this is actually just equals the integral of 10 times 1 over 25 plus x squared, because remember you can just bring the constant out, and in an integral you can multiply by the scalar afterwards. In fact, you could also say this is equal to 10 times the integral of 1 over 25 plus x squared. So this is equal to, now we can see here, a is equal to 5, so it's going to be 10 times 1 over 5 tangent inverse of x over a is equal to 5, plus c, which is equal to 2 tangent inverse of x over 5 plus c. So, quite a simple example. Once again, we'll get into much more interesting things later. Let's look at a second example, maybe a definite integral, which you should know how that works from higher maths. So if we have the integral of pi over 2, well, from pi over 4 to pi over 2, of secant squared of 2x plus pi over 4, we're integrating it with respect to x, then this is going to be equal to, so remember we put square brackets, to put inside we put the actual integral, and then we'll put the borders sort of at the end of the brackets. So, the integral of secant squared of 2x plus pi over 4. Now, clearly we're going to be using this expression, it's secant squared is integral of secant squared respect to x is equal to 1 over a tangent of ax plus c. But now we have a bigger function inside, we have a function of the form ax plus b on the inside. But that actually won't change that much, because in our u prime v prime is still going to be a, so the only difference is inside the tangent is going to be tangent of ax plus b. But a is still equal to 2, so it's going to be 1 over 2 tangent of, so we keep the inside identical, so here, and then our borders are pi over 2 and pi over 4. So now to evaluate the definite integral, in fact we could take the half out of the brackets, because the scalar is going to be on both subtractions. We'll not do it just for this time. So this is equal to half tangent of 2 times pi over 2 plus pi over 4 minus half tangent of 2 times pi over 4 plus pi over 4, which is equal to, so tangent of 2 pi over 2 is pi, plus pi over 4, so if we look at our unit circle or the wave, whichever one you prefer to work with, so I prefer working with a unit circle. If you're not familiar with that, you can think about it using sine and cosine waves. So if we think about the exact value of pi plus pi over 4, which is 5 pi over 4, so here this is 0, this is pi over 2, this is pi, and then 5 pi over 4 is here, so this is the ratio, well, sine is negative root 2 over 2 and cosine is negative root 2 over 2, so the tangent of this is simply equal to 1 and times a half, so 1/2, minus 1/2, so 2 times pi over 4 is pi over 2, plus pi over 4 is 3 pi over 4, this is pi over 4, 2 pi over 4, 3 pi over 4, so cosine of 3 pi over 4 is equal to negative root 2 over 2, and sine of 3 pi over 4 is equal to root 2 over 2, so tangent is equal to negative 1, so negative 1 times 1/2 minus 1/2, which is equal to 1, so this integral is simply equal to 1. See you in the next video for some much more interesting integrations.